Welcome to the Sleepy Brain Dose. Here we drift together into calm science for sleep-gentle facts and quiet wonders, told in a soft rhythm that helps the mind slow down. Tonight, we'll explore the architecture of the universe, the cosmic web. Of filaments and voids, the largest pattern in existence. Settle in, let your breath find its pace, and allow the story of the cosmos to guide you into rest. You may allow your breath to slow as we begin, as if each inhale and exhale were gently tracing the rhythm of space itself. The subject is large, almost unimaginably large, yet the way we will move through it will be soft, patient, unhurried. Tonight we will begin by considering the scale of the cosmos dot. When we talk about scale, we often reach for numbers. We try to measure, to quantify, to give the vastness a shape we can hold in thought. But numbers alone can feel sharp, almost overwhelming. So let us approach differently. Let us imagine space as a rhythm, a slow unfolding that stretches further than any horizon we know. It is not a horizon of mountains or seas, but a horizon of silence and darkness, filled with quiet points of light. The earth beneath you is vast compared to your body. You may sense its firmness, the ground holding you securely, rotating steadily every day. Already, this is larger than our senses can grasp. And yet the earth is a small planet orbiting an ordinary star. The sun, though it sustains all life we know, is but a single star among hundreds of billions in our galaxy. Our galaxy. The Milky Way is a spiral disk of stars stretching 100,000 light-years across. If you let your mind picture this size, it is helpful to recall what a light-year means. It is the distance light travels in 1 year, moving at 300,000 kilometers every second. In 1 second, light circles the Earth 7 times. In 1 year, it crosses nearly 10 trillion kilometers. And the galaxy spans 100,000 of those light years. Already the scale feels as if it slips away from us. That is natural. You do not need to hold it tightly. You can simply rest. In the sense that this is beyond the grasp of daily thought, the Milky Way is not alone. Around it are neighboring galaxies, Andromeda, the Magellanic Clouds, smaller companions bound together in what astronomers call the local group. This cluster is itself only one small piece of a larger structure called the Virgo Supercluster. The distances between galaxies are not empty in feeling, but they are truly empty of matter. There are vast stretches where a ray of light may travel millions of years before brushing against a star or a planet dot as we let our awareness rest on. The feeling of emptiness becomes a kind of softness, like a quiet night that never ends. In these spaces, time itself seems to expand. The rhythm of galaxies drifting apart is slower than any human lifetime, slower than the rise and fall of civilizations. The cosmos moves on scales where 10 million years can pass like the blink of an eye dot. To make sense of these scales, astronomers use comparisons. If the Earth were the size of a single grain of sand, then the Sun would be like a small ball the size of an orange. The Milky Way would then stretch thousands of kilometers. And the observable universe, the portion we can see with telescopes, would extend far beyond even that, perhaps the size of a planet itself in this metaphor. The observable universe has a diameter of about 93 billion light-years. That number is hard to say, harder still to imagine. You do not need to calculate it. It is enough to know that the universe is not only large, but layered. Planets within solar systems within galaxies, galaxies within clusters, clusters within superclusters. Each step outward multiplies the distances until numbers dissolve into silence. You may notice a gentle rhythm in this story, each scale contained within another, like nesting dolls of matter and space. Your breath continues slowly, a reminder that you do not need to solve these scales. You can simply sense the unfolding pattern. Astronomers sometimes describe the universe as homogeneous on the largest scales. That means that when you look far enough in any direction, the average distribution of galaxies appears roughly the same. It is a profound thought. No matter which way we gaze, the universe offers a similar rhythm of light and dark, of clusters and voids dot within this vastness. Our lives are smaller than the smallest punctuation mark on a page, and yet our awareness reaches out to contemplate all of it. The human mind, soft and fragile, is able to hold an image of billions of light years. This contrast can be a source of calm rather than fear. It shows us that our worries, our rushing thoughts, belong to one level of scale, while the universe itself unfolds on another, infinitely larger, infinitely slower. Consider the way time flows here on Earth. A minute feels long when we wait. An hour feels brief when we are absorbed. A human life spans perhaps 70 or 80 years. Against cosmic scales, this is a moment. Yet the rhythm of stars and galaxies is not hurried. It is not impatient. Stars burn for billions of years. Galaxies drift for billions more. Nothing in the universe is in a rush. That rhythm, when felt deeply, can bring a sense of security. You are not late. The cosmos is always vast, always unfolding, whether you act or rest. If you let your thoughts settle now, you might notice a kind of gentle quiet, as if space itself were a soft fabric stretching around you. This is what scale means in the calm science of the night. Not sharp numbers alone, but the atmosphere of immensity, the endless backdrop of stars, and the awareness that within it we are both tiny and connected. The scale of the cosmos is a reminder that everything is nested. Your breath within your body on the earth around the sun within the galaxy within the cosmic web. Each level holds the next, like layers of rhythm, steady and slow. In this way, scale becomes not overwhelming but soothing. It shows us our place, and in that place we can rest. You may notice your breath again, soft and steady, like a small current flowing through the body. In the quiet rhythm of this moment, we turn from the immensity of scale toward the building blocks themselves. We ask how stars, those luminous points we see in the night sky, come together to form galaxies. This journey is not rushed. It unfolds with patience, like a slow ripple spreading across still water-dot stars are born in clouds of gas and dust. These clouds, called nebulae, are enormous compared to our solar system. Inside them, gravity pulls material inward. Over millions of years, regions grow denser, until the pressure and temperature rise high enough for nuclear fusion to begin. At that moment, a star shines into existence. Each star is a kind of balance, gravity trying to pull matter inward, and radiation from fusion pushing outward. This quiet equilibrium allows stars to burn steadily for billions of years. You can imagine the Milky Way as a great city of stars, each one a glowing home. The sun is only one among hundreds of billions, and yet it feels central to us because it is ours. Around other stars, planets also circle, though most are invisible to us. Together, stars form systems, and systems collect into clusters. Step by step, gravity guides them to weave larger patterns. Galaxies are not scattered randomly. They are families of stars, bound together by mutual gravity. Some galaxies spin like spirals, with graceful arms curving outward. Others form as smooth ellipses, or as irregular shapes without clear symmetry. But whatever their form, they are. vast gatherings of stars. Our Milky Way contains perhaps 400 billion stars, and each of those stars is a sun in its own right, potentially with planets circling, perhaps even with life. When you look up at the night sky, most of the points of light you see are nearby stars within the Milky Way. Yet if your eyes are sharp, or if you use a telescope, some of those points are not stars at all, but distant galaxies. Andromeda, for example, appears as a faint smudge in the sky. It is not a single star, but a vast spiral galaxy larger than our own, containing over trillion suns. Already, it is on a slow collision course with the Milky Way, a meeting that will occur in about 4 billion years. That span of time is so long that it invites stillness. It is far beyond the urgency of human history. To understand galaxies is to see how stars are not isolated. Just as people form communities, stars also belong to larger patterns. But the comparison is gentle, not exact. Stars do not choose their companions. They drift into groups under the influence of gravity, gathering into swirls and arcs. Over time, these galaxies become the dominant structures we can see across the universe. Consider the energy of a single star. Our sun shines with power beyond comprehension, converting millions of tons of hydrogen into helium every second. Yet within a galaxy, that light is only one among billions. From a distance, the glow of a galaxy appears smooth, like a cloud. But it is really the combined light of countless stars. If you let this idea rest in your mind, it can feel like a gentle paradox. Each star is immense, yet in the vastness of a galaxy, it becomes only one soft note in a larger harmony. Galaxies are more than stars. They also hold gas, dust, and an invisible component called dark matter. The gas is the raw material for new stars. The dust scatters and reflects light, creating patterns we can observe. And the dark matter, though unseen, forms a kind of gravitational scaffolding holding the galaxy together. Without it, the stars would drift apart. Scientists still do not know exactly what dark matter is, but they can trace its presence in the way galaxies rotate. The process of galaxy formation is slow and patient. In the early universe, small irregular clumps of stars began to merge, combining into larger structures. Over billions of years, these mergers created the grand spirals and ellipticals we see today. Sometimes galaxies pass close to one another, their mutual gravity twisting them into new shapes. Sometimes they collide outright, blending their stars and triggering bursts of star formation. Even in these immense events, the scale is so large that stars rarely hit each other directly. Instead, they drift through, guided into new orbits, while the galaxies themselves merge. Our own Milky Way is shaped like a disk, with a bulge in the center and spiral arms reaching outward. The Sun lies on one of these arms, called the Orion Arm, about 27,000 light-years from the center. Around us, the galaxy rotates slowly, taking about 200 million years for one full turn. That is nearly 1,000 times longer than all of recorded human history. The galaxy's rhythm is vast, serene, almost timeless. When astronomers observe other galaxies, they see an extraordinary diversity. Some are dwarf galaxies, small collections with only a few billion stars. Others are giants with trillions. Some glow brightly with new star formation, while others are quiet, their fuel exhausted, their stars aging and fading. Yet together, all these galaxies form a cosmic tapestry. There may be 2 trillion galaxies in the observable universe. The number is so large that it ceases to be a number at all. It becomes a sense of endlessness, like a horizon that never ends. You may find comfort in noticing that galaxies are not isolated islands. They gather into groups and clusters, bound by their mutual gravity. Even galaxies, vast as they are, belong to larger families. The Milky Way and Andromeda are part of the local group, which itself belongs to the Virgo cluster. And beyond that lies the Laniakea supercluster, stretching over 500 million light years. Each level is both vast and connected, like breath within breath. When you reflect on this, you may sense a quiet humility. Our sun, our planet, our lives all are one thread in this immense weaving. Yet there is also reassurance. The cosmos has its own pace, its own rhythm, one of slowness and security. Stars burn for billions of years. Galaxies evolve over spans, so long they make mountains and oceans seem brief. Nothing here is hurried. Nothing is impatient. In the calm science of sleep, we do not need to solve every detail. It is enough to rest in the awareness that stars become galaxies, and galaxies become the scaffolding of the universe. Each level builds upon the last, forming a gentle sequence from the small to the immense. This rhythm of gathering of stars to galaxies is one of the quiet foundations of the cosmos. As you let this thought settle, you may notice a feeling of safety. The universe is vast and complex, yet its structures are steady. Stars will continue to burn. Galaxies will continue to rotate. And in their calm persistence, they remind us that we too can rest, breathing slowly, held in the softness of night. Let your breath fall into an easy rhythm, like a tide moving in and out. We have already spoken of stars joining into galaxies. Now we take another step outward, as gently as lifting our gaze to a slightly wider horizon. Galaxies, though vast, are not solitary. They too belong to larger gatherings, called clusters and superclusters. To rest with this thought is to sense again the nested nature of the cosmos. Patterns within patterns, families within families, each held together across unimaginable distances. A galaxy cluster is a community of galaxies bound by their mutual gravity. These clusters are not small. They may contain hundreds or even thousands of galaxies. Between them lies hot gas, stretched so thin that no human senses could detect it directly, yet glowing in X-rays that telescopes can measure. This gas, more than the galaxies themselves, carries most of the visible mass of the cluster. Around, and within it, dark matter forms an invisible skeleton, holding the cluster together. Without this unseen gravity, the galaxies would simply drift away. Our own Milky Way belongs to a modest neighborhood called the local group. This group contains about 50 galaxies, though most are small dwarfs. The largest members are the Milky Way itself, Andromeda, and the Triangulum Galaxy. The smaller companions orbit around them like satellites. Within the local group, galaxies drift slowly, interacting over spans of billions of years. The group has a diameter of roughly 10 million light years. Even at this smaller scale, the distances are almost impossible to grasp. Light, which feels instantaneous in daily life, would still take 10 million years to cross from one edge of our local group to the other. Yet, the local group is only one of many groups bound together in the Virgo cluster. The Virgo cluster contains about 2,000 galaxies, stretched across a region more than 50 million light years wide. It is the nearest large cluster to us, and it serves as a kind of anchor in our cosmic region. When astronomers measure the motions of galaxies, they find that both the Milky Way and Andromeda are slowly being drawn toward the center of the Virgo cluster, pulled by its gravity. The pace is slow beyond comprehension. Hundreds of millions of years will pass before the movement becomes clear, but the pull is steady. A reminder that even galaxies are part of something larger. Clusters vary in richness. Some are loose, with galaxies spread out like scattered lights across a field. Others are dense, with galaxies pressed close, colliding and merging more frequently. In the densest clusters, the central regions may be dominated by a giant elliptical galaxy, swollen by countless past mergers. These galaxies are ancient and quiet, their fuel largely consumed, their light steady but subdued. Around them, younger spiral galaxies continue to form stars, their arms glowing with blue light. The contrast is gentle but instructive. Within a single cluster, we see the stages of galactic life arranged side by side. Superclusters extend the pattern one step further. A supercluster is a collection of clusters and groups, a network of galaxies stretching hundreds of millions of light years. Our local group and the Virgo cluster belong to a vast structure called the Laniakea supercluster. The word Laniakea comes from the Hawaiian language and means immense heaven. It is an apt name, for this supercluster spans more than 500 million light years. It contains around 100,000 galaxies, each a city of stars, each with its own planets, histories, and rhythms. Supercluster are not simple spheres of galaxies. They form elongated patterns, strands, and walls that resemble filaments, woven across the cosmos. Between them lie enormous voids, regions with few galaxies at all. This architecture, the filaments, clusters, and voids, is sometimes called the cosmic web. It is the large-scale structure of the universe, the pattern we see when we zoom far enough out. Galaxies, clusters, and superclusters are the threads in this web, stretched by gravity and shaped by the unseen hand of dark matter. The Coma cluster is another example, farther from us than Virgo, but even richer. It contains thousands of galaxies, held together in a dense sphere more than 300 million light years away. When astronomers observe the Coma cluster, they see galaxies orbiting the cluster's center at high speeds. These motions were one of the first clues to the existence of dark matter, for the visible galaxies alone could not account for the gravity required to hold them in place. The cluster, quiet in appearance, whispered of an invisible presence, a hidden structure underlying the visible dot clusters and superclusters. Teach us that the universe is not random. It has order, not in the sense of symmetry or perfection, but in the sense of patterns repeating across scales. Just as stars gather into galaxies, galaxies gather into clusters. Just as clusters join into superclusters, those superclusters connect into the cosmic web. The nesting continues outward until it reaches the largest scales we can observe. At that level, the distribution becomes nearly uniform, smooth in its averages. The rhythm of clustering dissolves into a background that looks the same in every direction. For us, this knowledge is a quiet reminder of connection. The Milky Way is not drifting alone through emptiness. It belongs to the local group, which belongs to the Virgo cluster, which belongs to Laniakea. We are one thread in a vast and gentle tapestry. Each level is held within another, like concentric shells of belonging. To rest in this awareness is to feel that we too are held, our small lives enfolded within patterns larger than we can see. The timescales involved are equally calming. Galaxies orbit within clusters over billions of years. Superclusters evolve over even longer spans. The movements are so slow that from our perspective, they are nearly still. The night sky appears fixed because the rhythms that shape it are vast. Nothing in these structures is rushed. Their patience can remind us of patience within ourselves. Just as clusters wait calmly for gravity to do its work, we too can pause, breathe, And let the slow rhythm of time guide us. When you picture a cluster, you might imagine a loose gathering of faint lights suspended in a dark sea. When you imagine a supercluster, you might picture strands of galaxies stretching like threads across a quiet fabric. These images are not meant to be exact maps. They are gentle aids for the mind, helping us hold the idea that the universe is organized into levels of belonging. You do not need to grasp the full distances or numbers. It is enough to sense the rhythm: galaxies to clusters, clusters to superclusters, superclusters to the cosmic web. This rhythm is the architecture of the universe, slow, immense, and serene. It is the background against which all smaller stories unfold: the story of the earth, of life, of our own thoughts as we listen now. To rest with clusters and superclusters is to let go of urgency. The universe is vast, and within its embrace there is room for quiet. You may notice your breath again, quiet and steady, as we turn to the story of discovery. Until now, we have looked outward step by step, from stars to galaxies, from galaxies to clusters, from clusters to superclusters. In this part, we ask how humans, on a small planet under a fragile sky, came to recognize that these structures form a grander pattern. It is the discovery of the cosmic web, the vast network of filaments and voids that shape the universe itself. For most of human history, the night sky was a dome of scattered lights. The stars seemed fixed, eternal. Even when telescopes revealed that some faint smudges were galaxies, the assumption remained that galaxies were sprinkled through space at random, like grains of salt scattered on a table. The true architecture was hidden, veiled by distance and darkness. The change began with the first large surveys of the sky. In the mid-20th century, astronomers started to record not only the positions of galaxies, but also their redshifts, the measure of how much their light is stretched by the expansion of the universe. By combining position and redshift, they could create three-dimensional maps. These maps revealed not only where galaxies appeared on the sky, but also how far away they were dotted first. The data was sparse, like faint sketches on a page. Yet patterns began to emerge. Galaxies were not evenly distributed. They gathered into chains, walls, and sheets. Between them lay enormous gaps, regions nearly empty of galaxies. These were the voids, silent expanses where light itself could travel for hundreds of millions of years without meeting a single star. One of the first dramatic demonstrations came in the 1980s with the CFA redshift survey in the United States. Astronomers Margaret Geller and John Huckra mapped the distribution of galaxies in a wedge-shaped slice of the universe. What they saw astonished them. Galaxies arranged along thin filaments, outlining vast bubbles of emptiness. It looked almost like a sponge, with dense walls surrounding empty holes. This was not random. It was a structure, grand and coherent. The maps grew richer as technology advanced. Telescopes scanned deeper, computers processed larger datasets, and supercomputers simulated cosmic evolution. The Sloan Digital Sky Survey, beginning in the late 1990s, revealed millions of galaxies across huge portions of the sky. With each new survey, the same pattern appeared: filaments of galaxies, knots where they met, and voids between them. The cosmic web had become unmistakable. What is striking is not only the scale, but also the familiarity of the pattern. The web of galaxies resembles structures we know on Earth: the branching of rivers, the network of roots and mycelium beneath the forest floor, even the web of neurons in a brain. These analogies are not exact, yet they bring comfort. They remind us that patterns repeat, that nature echoes itself across scales. The universe is immense, but its shapes feel strangely close. The discovery of the cosmic web also transformed cosmology. It showed that the universe is not only expanding, but also structured. The patterns we see today are the result of small ripples in the early universe, amplified over billions of years by gravity and dark matter. Where matter was slightly denser, gravity drew more material in, creating filaments. Where matter was thinner, voids expanded. Slowly, patiently, the universe grew a network, a quiet architecture stretching across billions of light years. From our perspective, the web is frozen. The shapes change so slowly that human history is a blink compared to their rhythm. Yet through simulations, we can watch the story unfold. Starting with the nearly uniform early universe, computer models show filaments forming, clusters condensing, voids widening. These simulations confirm what the surveys revealed, that the web is real, and that it emerges naturally from the laws of physics. There is a gentle humility in remembering how recent this discovery is. Less than half a century ago, we did not know that the universe had such a structure. For thousands of years, the cosmos was thought to be a fixed dome, then an empty stage for galaxies, and only now do we see it as a web, alive with hidden connections. Our understanding continues to grow, yet the rhythm of discovery is slow and patient. Like the unfolding of night into dawn, the term cosmic web captures both the shape and the feeling. It is not a rigid grid, but a delicate network, a lacework of matter stretched across the sky. To imagine it is to picture filaments glowing softly, linking clusters like beads on invisible threads. The voids are not frightening. They are spaces of calm, regions of silence that give the web its form. Without emptiness, there would be no pattern, only a blur. The contrast creates the rhythm. You do not need to hold the numbers hundreds of, millions of light years, billions of galaxies, trillions of stars. It is enough to rest in the sense that the universe is both vast and ordered. There is a structure, and within it, we have a place. The cosmic web is not separate from us. Our galaxy is one filament in this network. The sun, the earth, your breath, are all part of the same unfolding dot. As you let this thought settle, you may notice a feeling of safety. The universe is immense, yet its structure is gentle. The discovery of the web is not a story of chaos, but of connection. It shows us that matter, from the smallest atoms to the largest clusters, is drawn into patterns. To rest with this knowledge is to feel that you, too, are woven into a larger whole. You may take a slow breath, letting it move in and out like the steady sweep of the night sky across the horizon. Our next step in this calm exploration is to consider how humans have mapped the universe. The stars above us appear countless, scattered like soft grains of light. To make sense of them, we draw maps. These maps are not only charts of position, but also records of our curiosity, our patient desire to know where we are in the great immensity. The earliest maps of the heavens were simple patterns drawn by the eye. Ancient observers watched the stars rise and set, season after season. They traced constellations, figures of animals, heroes, and objects that helped them remember the positions of bright stars. These constellations were not scientific in the modern sense, yet they served as the first framework of the sky. They gave orientation, rhythm, and meaning. For thousands of years, sailors guided their ships by these patterns. Farmers measured seasons by the reappearance of certain stars at dawn. As tools improved, so did the maps. The invention of the telescope in the 17th century revealed that the sky held far more stars than could be seen with the naked eye. Astronomers began to catalog them, assigning numbers and coordinates. Star charts grew denser, covering the heavens with thousands of entries. The sense of wonder deepened. The more we looked, the more there was to see. In the 18th and 19th centuries, astronomers like Charles Messier and William Herschel expanded these maps further. Messier created a catalog of faint, fuzzy objects, nebulae, and clusters that might be confused with comets. Herschel, with his powerful telescopes, attempted to map the structure of the Milky Way itself by counting stars in every direction. His maps suggested that our galaxy was a flattened disk, though the details remained uncertain. Even then, the idea of structure was emerging. The 20th century brought a revolution. In 1924, Edwin Hubble showed that the faint smudges called spiral nebulae were actually galaxies far beyond the Milky Way. The universe had expanded in our imagination, and mapping it required a new scale. Astronomers began to chart not only stars, but entire galaxies, each one containing billions of suns. The key to mapping in 3 dimensions came from redshift. Light from distant galaxies is stretched as the universe expands, shifting toward the red end of the spectrum. By measuring this redshift, astronomers can estimate how far away a galaxy lies. Combining position and distance, they can build 3-dimensional maps, like a cosmic cartography extending into depth as well as breadth. The first such surveys in the mid-20th century were limited, recording only hundreds or thousands of galaxies. Yet even these early maps hinted at clustering. Galaxies were not sprinkled evenly. They formed chains, groups, and walls. The patterns were faint but unmistakable. Like the first strokes of a sketch dot by the 1980s, technology allowed for deeper surveys. The CFA Redshift Survey, carried out in Harvard and the Smithsonian Astrophysical Observatory, produced a wedge-shaped map of the nearby universe. In it, galaxies appeared as dots, each placed at its measured distance. Together, they formed filaments surrounding great voids. The image astonished astronomers. For the first time, the large-scale structure of the universe was visible, not as theory, but as observation. As decades passed, the maps grew richer. The Sloan Digital Sky Survey, beginning in 2000, used a dedicated telescope to scan vast swaths of the sky. It recorded spectra and positions for millions of galaxies. The resulting maps revealed the cosmic web in extraordinary detail. Filaments stretching across hundreds of millions of light years, clusters glowing at their intersections, voids yawning in between. These were not random clouds of points. They were organized structures, drawn by gravity and dark matter over cosmic time. Mapping the sky is not limited to visible light. Telescopes now chart the heavens in radio waves, infrared, ultraviolet, X-rays, and gamma rays. Each wavelength reveals different features. Radio surveys show cold gas. Infrared sees through dust. X-rays reveal hot plasma in clusters. Together, these maps form a multi-layered atlas, richer than any one view could provide. There is also a map older than galaxies, older than stars, the cosmic microwave background. This faint radiation, discovered in 1965, is the afterglow of the Big Bang. Satellites like COBE, WMAP, and Planck mapped it across the entire sky. The map appears nearly uniform, but with tiny variations in temperature ripples, only one part, in 100,000. These ripples are the seeds from which the cosmic web grew. To look at such a map is to see the blueprint of the universe, drawn when it was only 380,000 years old. The process of mapping is quiet and patient. Astronomers do not see the web at once. They record one galaxy, then another, until patterns emerge. The work is cumulative, built over generations. Each observation is a point. Together, they form a picture. It is a reminder that understanding comes not in sudden flashes, but in the steady gathering of detail, like breaths joined into a rhythm. From a human perspective, these maps are enormous. They stretch billions of light years, containing millions of galaxies. Yet they are also fragile, drawn from faint photons that traveled across eons to reach our instruments. A telescope opens its shutter for hours, gathering a trickle of light, and from that trickle, a point is placed on the map. The vastness of the cosmos rests on such delicate signals, and still, the maps are not complete. Beyond the observable universe lies more that we cannot reach, hidden by distance and the speed of light. Even within our observable region, dust in the Milky Way blocks parts of the sky, leaving gaps. Mapping the cosmos is like drawing an immense landscape while standing in a small clearing. We trace what we can see and imagine the rest. To rest with these maps is to feel both humility and connection. We are small, yet we are capable of charting the universe itself. Our minds, fragile and brief, can hold images of billions of light years. The maps remind us that knowledge is a journey, not a final picture. The cosmos does not need to be fully grasped to be meaningful. Its shapes, patiently revealed, are already enough to bring calm. As you breathe now, you may imagine the maps as gentle threads stretching outward, each dot a galaxy, each line a filament, each gap a void. The sky is not random. It is a quiet architecture, slowly uncovered by human hands. To lie under the stars is to be both part of the map and the one who draws it. In that duality, there is peace. Take a slow breath in and let it out gently, as if the air itself were drifting through a quiet channel. In the same way, matter in the universe drifts, guided not by wind, but by gravity, gathering into long, delicate structures we call filaments. These cosmic filaments are the largest structures we know, strands of galaxies and dark matter stretching across billions of light years. To understand them is to glimpse the framework of the universe itself. When astronomers first mapped the cosmos in 3 dimensions, they saw that galaxies were not sprinkled randomly. Instead, they formed patterns, like threads woven into a web. These threads are the filaments. Imagine vast highways of galaxies, lined up along invisible paths. At their intersections, clusters form dense knots of hundreds or thousands of galaxies. Between them lie immense voids, regions with very little matter. Together, the filaments and voids create the cosmic web. A filament is not a solid structure. It is not like a rope or a cord. It is more like a faint river of galaxies, guided by gravity and dark matter. Along these rivers, gas flows as well, feeding galaxies and allowing new stars to form. The filaments are not only scaffolding, but also channels of nourishment, carrying material where it is needed. The scale is almost beyond imagining. A single filament may extend hundreds of millions of light years. If you could travel at the speed of light, it would still take you hundreds of millions of years to cross from one end to the other. Each filament contains countless galaxies, and each galaxy contains billions of stars. Within those stars may orbit planets, and on some planets, perhaps life. To picture this is to sense the immensity of connection, a chain that stretches across the cosmos, linking worlds we will never see. The filaments form slowly from the faint ripples in the early universe. After the Big Bang, matter was nearly uniform, with only slight variations in density. Over billions of years, gravity amplified these variations. Where matter was denser, it pulled more material inward, forming filaments. Where matter was thinner, voids expanded. The result after 13 billion years, is the cosmic web we see today. Dark matter plays a central role. Though invisible, it makes up most of the mass in the universe. It does not emit or absorb light, but it exerts gravity. Filaments are shaped by dark matter, with ordinary matter gas, stars, galaxies, falling into the gravitational wells it creates. In this sense, the filaments are like outlines drawn by something unseen, traced in visible light only because galaxies follow. Their paths, observing filaments is not easy. They are too large and too faint to see directly. Instead, astronomers infer their presence from the distribution of galaxies, from the bending of light called gravitational lensing, and from the faint glow of hot gas that fills them. Computer simulations also reveal their shapes, showing how filaments connect clusters and span the cosmos like the veins of a vast organism. The largest known filaments bear names that echo their scale: the Sloan Great Wall, stretching more than 1 billion light years; the Hercules Corona Borealis Great Wall, possibly even larger. These names sound immense, but they are simply the brightest threads in a much wider web. Filaments crisscross the universe in every direction, forming the true skeleton of cosmic architecture. It can be soothing to think of filaments not as distant abstractions, but as patterns of connection. Just as rivers link mountains to seas, just as roots link a tree to the soil, the filaments link galaxies across space. They remind us that even the largest scales are networks, not isolated points. Everything belongs to something larger, and that belonging has its own quiet rhythm. From our position in the Milky Way, we are part of such a filament. Our galaxy sits within the Laniakea supercluster, connected to neighboring clusters by strands of galaxies and dark matter. Though we cannot see the filament with our eyes, we can know it through observation and theory. It is part of our cosmic address, as real as the continent and ocean beneath us. To rest with this knowledge is to feel a sense of placement. You are here, on Earth, within the solar system, within the Milky Way, within a filament of the cosmic web. Each layer is steady. Each layer enfolds the next. The scale is vast, yet the structure is simple: strands and knots, filaments and voids. The complexity of galaxies reduces to a pattern both elegant and calm. Filaments also remind us of time. They formed over billions of years, and they will persist for billions more. Stars will be born, galaxies will collide, clusters will shift, but the filaments themselves will endure, slowly stretching as the universe expands. Their patience is immense. They change, but they do not hurry. This rhythm of slowness can guide us too. We do not need to rush. The universe unfolds in its own time, and we are allowed to rest within it. Some scientists describe filaments as the highways of the universe, along which galaxies migrate. Others call them the skeleton or the scaffolding. Whatever the metaphor, the meaning is the same. Filaments give structure to the cosmos. Without them, galaxies would be scattered, and the universe would lack coherence. With them, the universe is connected, graceful, and whole. As you breathe now, you might picture a filament as a soft line of light stretching across a dark canvas. Along the line, galaxies shine like beads on a thread. Between the lines, emptiness opens, quiet and undisturbed. Together, they form a pattern both vast and gentle. You do not need to see every detail. It is enough to know that the pattern exists, that it holds us, and that within it, you are safe. Let your breath fall into a slow rhythm, as though each inhale opened space within you, and each exhale softened it again. In the same way, the universe itself holds vast spaces, quiet and nearly empty. These are the cosmic void's immense regions, where galaxies are rare, where light may travel for hundreds of millions of years without touching a single star. To speak of voids is not to evoke absence or loss, but to notice how silence, too, has a place in the architecture of the universe. When astronomers first mapped galaxies in 3 dimensions, they saw not only the filaments and clusters, but also the great gaps between them. At first, these gaps seemed surprising. If the universe contained billions of galaxies, why would there be places with almost none? Yet as maps grew larger, the pattern became clear. Voids are not anomalies, but essential parts of the cosmic web. They are the spaces that allow the filaments to stand out, the rests that make the music of the cosmos audible. A typical void may span 100 million light-years across. Some are smaller, some are larger, and the very largest known voids stretch nearly 1 billion light-years. Within them, galaxies are few and far between. The matter that does exist is spread thin, often too diffuse to form stars. From the perspective of an observer inside such a void, the universe would appear dimmer, with fewer galaxies on the sky. The silence of space would feel deeper. The most famous example is the Boat's Void, discovered in 1981. It is nearly 330 million light-years across and contains far fewer galaxies than expected. At first, astronomers wondered whether it was truly empty. Later observations revealed that it does contain some galaxies, but still far fewer than average. It is a cavity in the cosmic web, a vast bubble of quiet, bordered by filaments where galaxies cluster more densely. The Boat's Void is not unique. It is one of many such spaces, woven into the rhythm of the universe. How do voids form? In the early universe, matter was distributed almost evenly, with tiny fluctuations in density. Over time, gravity amplified the denser regions, pulling more material inward to form filaments and clusters. The less dense regions, by contrast, lost matter as it flowed outward. These regions became emptier and expanded, forming voids. The process is natural, like water draining from valleys into rivers. The universe carves its own landscape, not of hills and valleys, but of filaments. And voids, although voids seem empty, they are not entirely barren. Some contain isolated galaxies, drifting far from their neighbors. These galaxies tend to be smaller, less massive, and often irregular in shape. They live in solitude, forming stars slowly, without the interactions and mergers that shape galaxies. In denser regions, to imagine such a galaxy is to picture a small lantern glowing in a vast dark plane, steady and quiet. Voids are also places of calm in the cosmic flow. While clusters and filaments are full of motion, galaxies colliding, gas, compressing, stars forming the voids evolve more gently. Their expansion is driven mainly by dark energy, the mysterious force causing the universe to accelerate in its growth. In voids, where gravity is weak, dark energy's influence is stronger. This makes voids expand faster than the rest of the cosmos, slowly stretching wider, like soft bubbles inflating in the fabric of space. For cosmologists, voids are not empty of meaning. They are laboratories for studying dark energy, dark matter, and the geometry of the universe. The way voids expand, the way light bends as it passes through them, all reveal clues about the hidden forces shaping the cosmos. In their silence, voids whisper truths about the universe's deepest laws. Yet beyond science, there is a more personal way to rest with voids. Emptiness, in human thought, is often linked with fear of nothingness, of absence. But in the cosmic web, emptiness has another role. It is not hostile. It is space that allows structure to appear. Without voids, the filaments would blur together, and the architecture of the universe would vanish. Silence gives shape to sound. Darkness allows light to be seen. Voids are the pauses that make the cosmic web into a pattern. You might imagine a void now, not as a threatening abyss, but as a wide open field under night sky. It is spacious, unhurried, free of clutter. Its stillness is soothing, like the pause between breaths. The galaxies at its edges shine all the brighter because of the emptiness between them. From our position, the Milky Way lies not inside a vast void, but near the boundaries of filaments. Yet we are close enough to sense their presence. Surveys show that our region of the universe includes voids and walls interwoven, like hollows and ridges in a landscape. Our cosmic address is not at the center of fullness, nor in complete emptiness, but balanced between. This too has a calming quality. We are part of the rhythm, not outside it. The timescales of voids are immense. They expand over billions of years, their edges shaped slowly by the pull of surrounding matter. Human history, by comparison, is a flicker. Civilizations rise and fall, while the voids remain unchanged. Their patience is vast, their silence unbroken. To contemplate them is to feel the smallness of urgency, the lightness of our daily concerns. The universe holds spaces of calm that endure across eons. In meditative traditions, silence is often valued as deeply as sound. The pause between notes is as important as the notes themselves. In the same way, voids are as important to the universe as galaxies. They remind us that absence is not failure. It is part of the whole. To rest in their image is to accept spaciousness within ourselves, to allow quiet as naturally as we allow breath. As you breathe again, you may sense that cosmic voids are not places of fear, but of reassurance. They are the wide, soft spaces that make the web of the cosmos visible. Without them, there would be no pattern, no rhythm. With them, the universe becomes a gentle architecture of light and silence, woven together across unimaginable distances. Allow your breath to settle into its rhythm again, steady and unforced. As the chest rises and falls, you might think of another rhythm, one that has guided the universe from its very beginning. It is the rhythm of gravity. Gravity is the quiet sculptor of the cosmos, shaping galaxies, clusters, filaments, and voids. To reflect on its dynamics is to sense the patient hand that holds the universe together. Gravity is familiar in daily life. It is what keeps your body resting on the ground, what pulls a dropped object downward, what holds oceans to the earth. Yet the same force extends across space, binding stars into galaxies and galaxies into clusters. The law is simple, but the scale is immense. Every piece of matter attracts every other piece. The pull grows weaker with distance, but it never vanishes. Even across billions of light years, the threads of gravity stretch unbroken. In the early universe, matter was spread almost evenly. There were tiny fluctuations, regions slightly denser than others. Gravity magnified these differences. Where density was higher, matter attracted more matter, growing denser still. Where density was lower, matter drifted away, leaving voids. Over billions of years, this feedback created the cosmic web. Filaments condensed, clusters thickened, voids widened. Gravity, constant and patient, orchestrated the process. You might imagine a vast sheet with small ripples. Place tiny weights on the sheet, and the ripples deepen, drawing more material inward. Over time, valleys form, rivers of matter flow toward them, and the sheet becomes patterned. This image is simple, yet it echoes the way gravity sculpts space. Itself, matter bends space, and bent space guides matter. The universe is not static. It is dynamic, with gravity shaping its flow like a steady tide. Within galaxies, gravity holds stars in orbit. The sun circles the center of the Milky Way once every 200 million years. Billions of stars follow their own paths, balanced between motion and pull. Without gravity, galaxies would dissolve into scattered light. With it, they remain coherent, graceful spirals or calm ellipses, turning slowly across cosmic time docked in clusters. Gravity binds hundreds or thousands of galaxies. These galaxies move rapidly, sometimes at thousands of kilometers per second, yet they remain bound, like bees swarming in a hive. A hot gas that fills clusters, the faint background of dark matter, all of it is gathered by gravity. The cluster becomes a single system, larger than any galaxy, held together by an invisible hand dot at the intersections of filaments. Gravity builds knots. Galaxies converge there, colliding and merging. Yet even these events, which sound violent in words, unfold slowly. When galaxies collide, stars usually pass one another without contact. Their orbits shift, their gas compresses, new stars form, but the process spans hundreds of millions of years. The pace is not abrupt. It is unhurried, patient, guided by gravity's calm rhythm. Voids, too, are shaped by gravity. As dense regions pulled matter inward, the surrounding areas grew emptier. Gravity did not abandon these places, it simply redirected matter away. In this way, gravity sculpts absence as well as presence. The voids expand, while the filaments concentrate. Together, they form the architecture of the cosmic web. Dark matter deepens the story. Though invisible, it provides most of the gravitational pull in the universe. Ordinary matter stars, gas. Planets makes up only a fraction. Without dark matter, galaxies would spin apart, clusters would unravel, and the web itself would collapse. Gravity is not only what we see, but also what we cannot. The hidden weight of dark matter shapes the paths of galaxies, bends light across space, and outlines the filaments of the universe. The dynamics of gravity are not rigid. They evolve with time. In the early universe, when matter was dense, gravity worked quickly, gathering material into clumps. As the universe expanded, matter grew more diffuse, and gravity's work slowed. Now, billions of years later, gravity competes with dark energy, which pushes the universe apart. On smaller scales, gravity still binds galaxies and clusters. On the largest scales, expansion dominates. The balance shifts gently, like a tide changing direction. Einstein's theory of general relativity teaches that gravity is not a force pulling through space, but the curvature of space itself. Matter bends the fabric of spacetime, and in response, other matter moves along those curves. The image of a sheet with weights is imperfect but useful. What matters most is the sense that gravity is geometry, not a rope or chain. It is the shape of the universe, guiding motion with quiet inevitability. This perspective adds a layer of calm. Gravity is not sudden or capricious. It does not switch on and off. It is steady, continuous, universal. From the fall of an apple to the orbit of galaxies, the same principle holds. To rest in this thought is to feel part of the stable order. The cosmos is vast, but it is not chaotic. Its dynamics have a rhythm, one that endures across eons. When astronomers simulate the universe, they often begin with small fluctuations in density and apply the laws of gravity. Over billions of simulated years, the cosmic web emerges naturally. Filaments stretch, voids expand, clusters form. The maps produced by these simulations match the maps observed by telescopes. It is as if the universe is playing out a single, patient pattern, written into its laws from the very beginning. To contemplate the dynamics of gravity is also to reflect on time. Human life is measured in years, decades, perhaps a century. The motions of galaxies take millions of years. The evolution of filaments spans billions. Gravity's rhythm is so slow that to us, the sky seems still. The constellations we know tonight are nearly the same as those known by ancient observers, though beneath that stillness, the stars are drifting. This slowness is soothing. It reminds us that not all change is abrupt. Some change unfolds with gentleness, almost imperceptibly. May notice now that the breath itself is an echo of gravity's rhythm. Inhaling, exhaling, rising, falling, each cycle steady, patient. Gravity is the cosmic breath, binding matter, shaping space, unfolding across eons. To rest in this rhythm is to feel that you, too, are part of it. Your life, your body, your breath, all held in the same geometry that guides galaxies. The dynamics of gravity are not only scientific facts, they are also invitations to calm. They show us that the universe is not random scattering, but an ordered flow. They show us that connection is not fragile, but deep, woven into the structure of space itself. And they show us that change need not be violent, but can be slow, enduring, and serene. As you breathe once more, you may picture the universe as a fabric gently curved, with galaxies drifting along its folds. The curves are vast, the motions slow, the pattern stable. Gravity holds it all together, not with urgency, but with patience. To rest with this thought is to feel safety in the cosmos, and to know that you, too, are carried by its rhythm. Allow your breath to lengthen for a moment, in and out, slow and even. As the air flows quietly, we turn our attention to something equally quiet yet immeasurably vast, dark matter. It is invisible, elusive, and still mysterious. Yet it forms the foundation of cosmic architecture. Without dark matter, the universe would look utterly different. To rest with this idea is to accept that sometimes the most important things are unseen, and still they hold us. Dark matter makes up about 85% of the matter in the universe. The stars, planets, gas, dust, everything we can see amount to less than 1/5 of the total. The rest is hidden. It does not shine. It does not absorb light. It does not interact with electromagnetic waves. And yet it reveals itself through gravity, bending the paths of galaxies, guiding the formation of filaments, shaping the cosmic web itself. The first hints of dark matter came from galaxies. In the 1970s, astronomer Vera Rubin studied how stars rotate around the centers of galaxies. According to Newton's laws, stars farther from the center should orbit more slowly, just as planets farther from the sun move more slowly. But Rubin observed something surprising. The stars at the edges of galaxies were moving just as fast as those near the center. It was as though an unseen weight was holding the galaxies together. Without this hidden mass, the galaxies should have spun apart long ago. Clusters of galaxies told the same story. In the 1930s, Fritz Zwicky measured the motions of galaxies in the Coma cluster. They were moving so rapidly that the visible matter, stars and gas, was not enough to hold them. He proposed that Dunkel Materie, dark matter, must be present. At the time, his idea was not widely accepted, but later observations confirmed it. Clusters, like galaxies, require far more mass than we can see. Gravitational lensing adds further proof. Light bends as it passes near massive objects. By studying how background galaxies appear distorted, astronomers can map the invisible distribution of mass in the foreground. These maps reveal vast halos of dark matter surrounding galaxies and clusters. The lensing patterns are too strong to be explained by visible matter alone. Something unseen must provide the extra pull-dot simulations of the universe, also depend on dark matter. When astronomers model cosmic evolution, starting from the tiny fluctuations in the early universe, they include both ordinary matter and dark matter. Over billions of years, the simulations show filaments, voids, and clusters forming. Without dark matter, the structures collapse too quickly or fail to form at all. With dark matter, the patterns match the universe we observe. The cosmic web is not only consistent with dark matter, it requires a dot. What, then, is dark matter made of? Here the answers are softer, more tentative. Many theories suggest that dark matter is composed of particles we have not yet detected, perhaps weakly interacting massive particles or axions or other possibilities. These particles would pass through ordinary matter almost without contact, invisible to our instruments. Experiments deep underground, shielded from cosmic rays, continue to search for them, listening for the faintest trace. So far, no detection has been conclusive. The mystery remains, yet the mystery does not diminish the role of dark matter. Even if we do not know its nature, we know its influence. It is like the wind shaping a landscape, unseen but evident in the forms it creates. It is like the roots beneath a forest, hidden but essential to the life above. Dark matter provides the gravitational scaffolding for galaxies. It outlines the filaments. It defines the voids. The visible universe is only the surface. The deeper structure is invisible. To rest with this thought is to consider how often the unseen holds more than the seen. Our daily lives are full of hidden influences, emotions, memories, gravity itself. We cannot see them directly, yet we feel their effects. Dark matter is the cosmic parallel, invisible, silent, but fundamental. It reminds us that reality is larger than what meets the eye. Even our own galaxy is wrapped in a dark matter halo. The Milky Way's stars, gas, and dust are only the luminous center. Surrounding it, extending far beyond the visible disk, is a vast sphere of dark matter. It is this halo that keeps the galaxy intact, that allows the sun to orbit safely, that provides the stability for life to exist on Earth. You are carried, at every moment, within this unseen structure. On the largest scales, dark matter threads the universe together. Imagine a web woven not of silk but of gravity, invisible yet strong. Along these threads, galaxies form like dewdrops, luminous and delicate. Between the threads, voids open, vast and silent. This is the cosmic web, and dark matter is its frame. Without it, the universe would dissolve into scattered fragments. With it, the universe becomes connected, ordered, and serene. There is comfort in knowing that the unknown can still be steady. Dark matter, though mysterious, provides security. It does not flicker. It does not vanish. It has been present since the beginning, shaping the cosmos for 13 billion years. Its patience is immeasurable. It changes slowly, if at all, across cosmic time. To rest with dark matter is to rest with the idea that some mysteries endure, and in their endurance, they give stability. Astronomers sometimes speak of the invisible universe. Dark matter and dark energy together make up about 95% of everything. The visible part, the stars, the galaxies, even our bodies, are only 5%. This proportion may seem humbling, even unsettling, but it can also be soothing. It means that what we see is only the surface of something deeper, like the tip of an iceberg above water. Beneath lies a hidden depth, silent and secure. As you breathe now, you might imagine yourself floating in this invisible sea. Around you, galaxies drift, luminous but small, compared to the vast halo of dark matter that holds them. The filaments extend outward, unseen but real, linking cluster to cluster, supercluster to supercluster. The web is not fragile. It is strong, ancient, and calm. You are part of it, not separate dot in this way. The role of dark matter is both scientific and meditative. It explains why galaxies exist, why the cosmic web has its shape, why the universe has structure. And it invites us to accept that not all truths need to be visible. Some can be trusted without being seen. Some can be felt through their effects, like the weight that holds the galaxy or the breath that sustains the body. Dark matter remains a mystery, but not a threat. It is a quiet foundation, a background presence, a steady hand. Its role is to connect, to bind, to shape. And in contemplating it, we find a reminder that the unseen can be gentle, that mystery can be calming, and that we, too, are held by forces we cannot see. Take a slow breath in and let it ease out again, gentle and steady. In the stillness of this rhythm, we turn now to a presence even more mysterious than dark matter. It is not simply invisible, but almost beyond description. Astronomers call it dark energy. Though unseen, it shapes the fate of the entire universe. It is the quiet, persistent force that causes space itself to expand ever faster, carrying galaxies away from one another, like leaves drifting apart on a widening stream. A long time, the universe was thought to be stable, or slowly slowing down. After the Big Bang, matter expanded outward, and gravity worked to pull it back together. Astronomers expected that over billions of years, the expansion would decelerate. Perhaps gravity would balance it, and the universe would settle into calm. Or perhaps gravity would eventually overcome it, causing the universe to collapse again in a big crunch. For decades, these seemed the only possibilities. But in the late 1990s, two teams of astronomers studying distant supernova exploding, stars used as standard candles for measuring cosmic distances, found something astonishing. The light from these supernovae was fainter than expected, which meant they were farther away than predicted. The universe was not slowing down, it was speeding up. Space itself was expanding faster and faster. To explain this acceleration, scientists introduced the concept of dark energy. It is not energy we can see or measure directly, but a property of space itself, a gentle pressure pushing outward. Unlike matter, which clumps together, dark energy remains smooth, spread evenly through the cosmos. As space grows, dark energy does not thin out. Instead, it continues to exert its effect, causing expansion to accelerate. Dark energy makes up about 70% of the universe. Dark matter accounts for another 25%, and ordinary matter, the stars, planets, and bodies, we know only 5%. This means that most of the universe is not just unseen, but also of a kind we do not yet understand. And yet, the effects of dark energy are clear. Galaxies are drifting apart, clusters are moving away, the fabric of space is stretching. The web of the universe itself is slowly expanding, its threads drawn more taut with time. The simplest explanation for dark energy is something Einstein once proposed: the cosmological constant. In his equations of general relativity, he added a term to keep the universe static. Later, when the universe was discovered to be expanding, he called it his greatest blunder. And yet, decades later, that same idea, the cosmological constant, fits perfectly with the observation of acceleration. It may be that space itself has an intrinsic energy, a vacuum energy that drives expansion. Other ideas, suggests that dark energy might change over time, or that it could be related to new fields, or forces not yet discovered. But for now, the details remain uncertain. The important thing is not the theory, but the effect. The universe expands faster, and the pace increases with time. What does this mean for the future? It means that galaxies not bound together by gravity will drift ever farther apart. Billions of years from now, distant galaxies will slip beyond the edge of visibility, carried away faster than light can travel. To observers in the far future, the night sky will look emptier, with fewer galaxies, fewer reminders of the cosmic web. The universe will still exist, but its visible richness will fade into isolation. Yet even this prospect is not a cause for fear. The timescales are immense, measured in trillions of years. Stars will live and die. Civilizations may rise and vanish. And still the expansion will continue, slow and steady, indifferent to urgency. The acceleration is not violent. It is gentle, patient, almost imperceptible on human timescales. To contemplate. It is to feel how brief our concerns are, how small our moment is within a rhythm that stretches across eternity. Dark energy also reminds us that the universe is not only matter in structure, but also emptiness given motion. It shows that space is not a passive backdrop. It is dynamic, active, with its own properties. Space itself breathes, in a sense, stretching wider with time. Just as you breathe in and your chest expands, so the cosmos breathes and its breath is eternal. Some describe dark energy as a repulsive force, the opposite of gravity. Others see it as a property of the vacuum, a quiet push built into the fabric of reality. However we describe it, the lesson is simple. The universe is expanding, and the expansion is accelerating. This is not chaos. It is order of another kind, a steady widening that has shaped the past and will guide the future. From a meditative view, dark energy can be seen as a metaphor for openness. It is the tendency of space to create more space, the rhythm of widening, the gift of room. In our own lives, we too may find expansion, moments where silence opens, where stillness creates more stillness. Just as dark energy stretches the cosmos, so breath stretches the body, gently, without forced thought. To rest with this thought is to feel no need for answers. We do not need to know what dark energy truly is to accept its role. It is enough to see its effect. Galaxies drifting apart, filaments stretching, the cosmic web expanding. It is enough to know that the universe holds mysteries still unfolding, mysteries that endure not as puzzles to be solved tonight, but as reminders that wonder never ends. As you breathe again, slowly and softly, you may imagine the universe itself. Inhaling, its fabric widening, its distances lengthening. The stars do not rush, the galaxies do not strain. All unfolds with patience. Dark energy is not a storm. It is a quiet tide, rising forever, carrying the cosmos gently outward. Let your breath find its gentle rhythm again, steady and soft. Each inhale opens space within, and each exhale releases tension. In the same way, scientists open space within their imagination and fill it with models of the universe. These are computer simulations, mathematical recreations of cosmic history, run inside the quiet hum of machines. They allow us to see how the universe might have unfolded, step by step, across billions of years. When we observe the cosmos, we see it in fragments. A telescope shows us galaxies at different distances, each one a snapshot from a different time. But we cannot watch the universe evolve directly. The timescales are too vast. Stars live for billions of years. Galaxies collide over hundreds of millions. Filaments form across eons. To see this story in motion, scientists turn to simulations. They write the laws of physics into code, set the conditions of the early universe, and let gravity, dark matter, and dark energy unfold on a digital stage. At first glance, it might seem impossible. How can a computer, no matter how powerful, recreate something as vast as the universe? The answer lies in scale and approximation. The simulation does not track every atom, every photon. Instead, it represents matter in large units particles, standing in for billions of stars or enormous clouds of gas. These particles interact through gravity and other forces, obeying the same rules that guide the real cosmos. Over time, patterns emerge: clusters, filaments, and voids, all shaped naturally from simple beginnings. One of the earliest and most famous projects was the Millennium Simulation, completed in 2005. Using more than 10 billion particles, it recreated the growth of cosmic structure in a cube of space 2 billion light-years wide. The result was a web of filaments and clusters that looked strikingly like the maps produced by telescopes. It confirmed that dark matter, when left to evolve under gravity, forms the backbone of the cosmic web. The luminous galaxies we see simply trace this hidden skeleton. Other simulations have gone further. Illustris, begun in 2014, modeled not only dark matter, but also gas, stars, and black holes. It followed the life cycles of galaxies, how they formed, merged, and grew. Its successor, Illustristing, covered even larger volumes, producing catalogs of virtual galaxies that could be compared directly with observations. The Eagle simulation in Europe, the Horizon Run in Korea, and many others have contributed to this digital cosmos, each offering a different resolution, a different window on the unfolding. What is most striking is how naturally the cosmic web appears. Starting from almost uniform conditions, tiny ripples in density, left over from the Big Bang simulations, produce filaments and voids with no extra instruction. The laws of physics alone generate the patterns. It is as though the universe contains within itself the blueprint of its structure, needing only time and gravity to reveal it. This simplicity is soothing. It tells us that order is not imposed from outside, but arises gently, inevitably, from the nature of things. Simulations are not perfect. They rely on assumptions about dark matter, dark energy, and the physics of star formation. They simplify processes that are too complex to model fully. Yet their imperfections do not erase their value. Instead, they offer a dialogue between theory and observation. If a simulation produces a pattern that matches the sky, confidence in the model grows. If it fails, scientists adjust the rules, learning more about what the universe requires. The process is iterative, patient, like refining a sketch until the lines match the landscape. The largest simulations today run on supercomputers, machines with thousands of processors working together. These computers hum quietly in cooled rooms, their circuits carrying out calculations that would take a human mind millions of lifetimes. In days or weeks, they trace billions of years of cosmic history. The scale is vast, but the rhythm is calm. The computer does not rush. It simply computes, step by step, until the structure appears. There is a meditative quality in watching the results. A cube of space fills with particles. At first, they are nearly uniform. Slowly, denser regions pull in more matter. Filaments stretch, clusters brighten, voids open. It is like watching frost grow on a window pane, or rivers carve valleys over time. The patterns are complex yet graceful, driven by simple laws repeated endlessly. Simulations also allow us to explore what cannot be observed. We can rewind the universe to its first seconds, or fast forward trillions of years. We can ask how the web would look if dark matter were absent, or if dark energy behaved differently. We can compare universes side by side, each with slightly different rules, and see which one resembles our own. In this way, simulations are laboratories of possibility. They remind us that knowledge is not fixed, but always expanding, like the cosmos itself. For the mind at rest, there is comfort in this method. It shows that the universe is understandable, not in every detail, but in its broad strokes. From simple beginnings, complexity emerges. From equations, patterns arise. From invisible forces, visible structures appear. To contemplate this is to see that order is not an illusion. It is real, woven into the fabric of space, you may imagine now. That the universe itself is a kind of simulation, though not on a machine, but within reality itself. The laws of physics are the code. The particles are the data. The unfolding of time is the computation. We do not need to solve it. We need only notice that it runs steadily, quietly, across billions of years. The cosmos itself is the great simulation. And we are among its outputs. Simulations are not only about science. They are also about perspective. They remind us that the patterns we see are not accidents, but natural outcomes. They remind us that the universe has patience, unfolding slowly, with no need to rush. And they remind us that we, small as we are, have the capacity to imagine the whole, to recreate it in numbers and lines of code, and to glimpse its beauty. As you breathe again, softly and steadily, you may picture a digital cosmos growing before you, particles glowing faintly, filaments stretching like threads of light, clusters forming at their knots. It is not chaotic. It is serene. It is not hurried. It is timeless. Computer simulations do not replace the real universe, but they allow us to see its rhythm more clearly. And in that rhythm, we can find rest. Take another slow breath, letting it rise and fall with ease. As your breath expands and contracts, imagine the universe expanding as well, carrying within it structures of unimaginable size. These are not single stars, nor single galaxies, but the largest patterns ever observed. They are the great walls and filaments of the cosmic web, the immense formations that stretch across billions of light years. To rest with them is to feel the scale of the cosmos in its quiet majesty. When astronomers first created three-dimensional maps of galaxies, they discovered more than clusters and filaments. They found enormous structures, so vast that they seemed almost beyond belief. These were not isolated threads, but great sheets of galaxies, forming boundaries around immense voids. Together, they gave the universe a honeycomb-like pattern walls enclosing cavities, filaments linking clusters, a cosmic architecture of staggering size. One of the earliest discoveries was the CFA2 Great Wall, revealed in the 1980s by the Center for Astrophysics Survey. It stretched more than 500 million light-years across, making it the largest known structure at the time. To imagine its size, recall that our galaxy is 100,000 light-years wide. The Great Wall was 5,000 times larger. And yet, to the universe itself, it is only one piece of a larger pattern. Later surveys revealed even grander formations. The Sloan Great Wall, discovered in 2003, spans about 1.4 billion light-years. It is a filament of galaxies bound together, in a sheet-like arrangement stretching far across the sky. Within it lie countless clusters, each containing thousands of galaxies, each galaxy containing billions of stars. The Sloan Great Wall is not a solid object, but a distribution, a rhythm of galaxies, arranged into a single structure by gravity's patient pull. Beyond even, this is the Hercules Corona Borealis Great Wall, first identified in 2013. It may extend more than 10 billion light-years, making it the largest known structure in the observable universe. Its size raises questions, for it challenges some expectations of cosmology. On scales this large, the universe should appear homogeneous, nearly the same in every direction. Yet here is a formation so vast that it seems to stretch across a tenth of the visible cosmos. Whether it is a single coherent structure or a chance alignment of many smaller ones remains debated. But either way, its immensity is humbling. These great walls are not the only giants. Other vast features include the Laniakea supercluster, our home region, which spans about 520 million light-years. Within it lies the Virgo cluster, the local group, and the Milky Way. Laniakea is not a wall, but a gravitational basin, a region where galaxies flow together, drawn toward a central point. It is our address in the cosmic web, a reminder that even the grandest scales have a place for us. Not the Shapley supercluster is another example, a concentration of thousands of galaxies located about 650 million light-years away. Its mass is so great that it influences the motion of our own galaxy, contributing to the flow of the local group across space. These flows, measured carefully, reveal how structures of enormous scale tug on galaxies, like leaves carried by a current dot. What unites all these structures is their rhythm. They did not appear suddenly. They formed slowly, over billions of years, from the small ripples of the early universe. Gravity amplified the denser regions, pulling more matter inward, stretching filaments, creating walls. Dark matter provided the scaffolding, while gas and stars filled in the visible threads. The process is patient, deliberate, unhurried. The largest known structures are simply the natural outcome of time and gravity working together. For the human mind, such scales are almost impossible to picture. Billions of light-years cannot be held fully in thought. Numbers dissolve into silence, but this is not a barrier. It is an invitation. You do not need to grasp the dimensions precisely. You can rest instead in the awareness that the universe holds patterns so large that they surpass comprehension. To know they exist is enough. From a meditative perspective, the largest structures embody connection. They show that galaxies are not isolated, that even clusters are linked into something greater. Just as filaments connect stars to galaxies and galaxies to clusters, the great walls connect clusters into superclusters, superclusters into networks. The pattern continues outward, each level held within the next. This nesting brings comfort. It assures us that nothing drifts alone. Observing these giants also deepens humility. The Earth, the solar system, even the Milky Way, these are small against the backdrop of walls billions of light-years wide. Yet the very fact that we can perceive them, that we can map their outlines, is extraordinary. Our minds, brief and fragile, are capable of reaching across the cosmos in thought. The act of knowing is itself a kind of participation. The largest known structures also remind us of impermanence. Though they seem eternal, they too will change. As the universe expands, galaxies not bound by gravity will drift apart. Over trillions of years, the cosmic web will thin, its threads stretched until they fade beyond sight. The great walls we see today will one day vanish from view, their light carried beyond the horizon of visibility. But for now, they stand as immense testaments to the universe's patient unfolding dot. To rest with these structures is to feel both awe and calm. Their size humbles the mind, but their stability soothes it. They do not flicker or rush. They endure, steady and vast, across billions of years. In their presence, human concerns feel lighter, as if set gently against a wider backdrop dot. As you breathe once more, you may imagine a wall of galaxies stretching silently across the dark. Each point of light is a sun, each cluster a city of stars, each thread a filament woven into a cosmic fabric. The scale is beyond measure, but the feeling is simple: vastness, order, serenity. The universe is larger than we can know, yet within it we are connected, held, and safe. Allow your breath to slow, as though it were keeping time with the wider rhythm of the cosmos. With each inhale, imagine space opening. With each exhale, imagine settling into that space. Now we turn our attention to something deeply grounding, our own place in the cosmic web. We have spoken of galaxies, clusters, filaments, and wall structures so immense that they feel almost beyond reach. Yet within this vastness, we have an address, a location woven into the network. To reflect on that address is to find both humility and comfort. We begin at the smallest scale familiar to us, the Earth. It is a planet orbiting a star, the Sun, in a system of 8 planets, countless asteroids, comets, and clouds of dust. The Earth is neither the largest nor the smallest world, but it is uniquely ours, the place where life has taken hold. For all its oceans, forests, and mountains, it is a thin shell compared to the cosmos, a fragile home circling quietly in space. The Sun, our star, is one of hundreds of billions within the Milky Way galaxy. The Milky Way is a barred spiral, stretching about 100,000 light-years across. We do not live at its center, but far from it, on a minor spiral arm known as the Orion arm. This location is neither the brightest nor the densest region of the galaxy. It is quieter, less crowded, a neighborhood of calm. Here the Sun makes its slow orbit around the galactic core, completing one rotation roughly every 225 million years. In the time since life began on Earth, the Sun has circled the galaxy perhaps only a dozen times. The Milky Way itself is not solitary. It belongs to a small collection called the Local Group. Alongside us are the Andromeda Galaxy, slightly larger and on a slow course toward us, and the Triangulum Galaxy, smaller but still luminous. Around them orbit dozens of dwarf galaxies, faint companions bound together by gravity. The Local Group spans about 10 million light-years, and within it, galaxies drift gently, drawn into slow dances that unfold across billions of years. But even the Local Group is not isolated. It is part of the Virgo cluster, a much larger gathering of thousands of galaxies, located about 65 million light-years away. The Virgo cluster itself sits within a gravitational basin known as the Laniakea Supercluster. Laniakea, whose name means immense heaven, stretches across 520 million light-years and contains around 100,000 galaxies. This is our greater cosmic home, the region of the web to which we belong. Within it, the Milky Way is but one thread, a small bead of light in a vast necklace. When astronomers trace the motion of galaxies in our region, they find that they are flowing toward a point called the Great Attractor. This is not a single object, but a concentration of mass clusters and superclusters, whose gravity draws galaxies toward it. Our galaxy, along with countless others, is part of this slow drift. It is a reminder that we are not fixed, but always moving, carried along pathways shaped by the web dot. Beyond Laniakea lie still larger walls and filaments, like the Sloan Great Wall and the Hercules Corona Borealis Great Wall. Yet even as these structures extend outward, our position remains grounded. We are here in the Milky Way, within the local group, within Laniakea. The nesting of these layers gives us a cosmic orientation, an address as real as a street or a city. To contemplate it is to feel not lost, but located. It is easy to imagine that such immensity would make us insignificant. And yet, the opposite can be true. Within this grand network, we are not outsiders. We are woven into the fabric. The atoms in our bodies were forged in stars, carried in galaxies, gathered along filaments shaped by dark matter. We are participants in the same processes that form the web itself. To know our place is to see that we belong fully to the cosmos. There is also comfort in the gentleness of these scales. The motions of galaxies are vast, but their pace is slow. Our galaxy orbits, clusters drift, filaments stretch, but all on timescales of hundreds of millions or billions of years. Nothing in the web is hurried. Nothing is unstable. From our perspective, the cosmic neighborhood is serene. If you close your eyes, you might picture the layers of our address as concentric circles. At the center is Earth, small and blue. Around it is the solar system, with its planets tracing calm ellipses. Around that lies the Milky Way, a spiral disk turning slowly. Beyond is the local group, a family of galaxies. Beyond that is the Virgo, cluster, dense with thousands of galaxies. And beyond still is Laniakea, an immense basin of light and gravity. Each circle encloses the next, each one a shelter within a larger shelter. This nesting gives a sense of safety. Just as a home is part of a neighborhood part of a city, and a city part of a continent, so too is our galaxy part of the web. Each layer supports the next. Each layer is held in place by gravity, by connection, by the quiet rhythm of the universe. To rest in this awareness is to feel secure. Enfolded by the architecture of the cosmos. Our place in the web is also a perspective. On scale, on the human scale, a lifetime is brief. On the planetary scale, civilizations rise and fall. On the galactic scale, stars are born and die. And on the cosmic scale, filaments stretch across eternity. Yet all these scales are connected. The breath you take now belongs to atoms forged in ancient stars, carried through the web, and gathered here on Earth. You are both local and cosmic, both immediate and eternal. From the scientific point of view, our place tells us how the universe is organized. From the meditative point of view, our place tells us that we are not separate. We are part of the pattern. Just as the Milky Way is one thread in Laniakea, so too are we one thread in the Milky Way. The sense of belonging is not forced, it is natural, written into the very fabric of reality. As you breathe again, slowly and gently, you may imagine the cosmic web as a vast net of light, with threads stretching in every direction. Somewhere within it lies a small spiral galaxy, and within that galaxy, a yellow star, and around that star, a blue planet. That planet is home. It is where you rest now, where you breathe. To know this is not to feel small. It is to feel connected too. The Earth to the galaxy, to the web, and to the universe that holds it all. Let your breath soften in and out, slow and steady. As we continue this journey, we turn to something that can bring the faraway closer. The cosmic web, though vast beyond measure, carries shapes that echo those we see in nature all around us. By tracing these analogies, we find connection. The universe does not seem so distant. Its patterns feel familiar, woven into life itself. The first and most often mentioned analogy is with the human brain. When astronomers compared maps of the cosmic web with microscopic images of neurons, the resemblance was striking. Both show branching networks, nodes linked by filaments, dense clusters joined by long, thin strands. In the brain, neurons carry signals. In the universe, galaxies trace gravity's paths. The scales are utterly different millimeters in the L. Brain, billions of light years in the cosmos. Yet the geometry is similar. Both are networks, both are patterns of connection. This resemblance is not exact, of course. The brain is alive, pulsing with electrical signals, while the cosmic web is quiet, shaped only by gravity. But the echo is soothing. It suggests that nature favors certain forms, repeating them across scales. Just as neurons link into thought, galaxies link into webs. Just as the brain is more than its individual cells, the universe is more than its individual galaxies. The whole emerges from the pattern dot. Another analogy comes from beneath the soil, the mycelium of fungi. Mycelium is a network of fine threads, weaving through the earth, connecting roots, sharing nutrients. It binds ecosystems together, often called the wood wide web. When viewed under a microscope, mycelium looks like a tangle of filaments, stretching across space. The cosmic web looks much the same, only far larger. Both are systems of distribution, carrying resources where they are needed: nutrients in the forest, gas and galaxies in the universe. Like mycelium, the cosmic web is not uniform. It has dense nodes where threads meet, and wide gaps between. In the forest, these nodes might be roots or trees. In the cosmos, they are clusters of galaxies. In both, the strength comes not from a single thread, but from the network as a whole. Each filament is delicate, yet together they form something resilient, enduring, and balanced. Rivers offer another analogy. Viewed from above, a river system branches into tributaries, then streams, then creeks. Water collects, flows, divides, and merges, forming a pattern of veins across the landscape. The cosmic web, mapped across the sky, looks similar. Galaxies flow along filaments as water flows along rivers, gathering into larger streams, merging into basins. The voids are the dry plains between rivers, wide and open. The flow is not of liquid, but of matter, guided by gravity instead of terrain. Yet the shapes match, reminding us that flow, branching, and connection are universal forms. Lightning, too, has a resemblance. A bolt splits into branches, dividing and rejoining as it crosses the sky. The pattern is fractal, repeating at different scales. The cosmic web shows similar branching, though frozen in time rather than flashing in an instant. What lightning does in a second, the cosmos does in billions of years. One is fierce and bright, the other calm and patient. Yet the geometry links them. Even the veins in leaves echo this design. A central vein branches into smaller ones, carrying water and nutrients to every part of the leaf. The structure is efficient, covering space evenly while minimizing effort. The cosmic web does the same, distributing galaxies across space in patterns that maximize balance. The visible beauty of a leaf and the invisible beauty of the universe share the same logic. Why do these analogies arise? Scientists call it self-organization. Simple rules repeated across time create complex patterns. In neurons, electrical impulses guide growth. In fungi, chemical signals spread. In rivers, water follows gravity downhill. In the universe, matter follows gravity across expanding space. Each system is different, yet the forms converge. Networks emerge, filaments stretch, nodes connect. It is as if nature prefers certain rhythms, repeating them from the microscopic to the cosmic dot. For us, these analogies are more than curiosities. They are bridges of understanding. They allow us to feel that the universe is not alien but related. The same shapes we see in forests, rivers, and bodies appear in the stars. The cosmos is not separate from life. It is the backdrop that carries life, and its patterns whisper through everything we know. There is comfort in this recognition. It suggests that the universe is not chaos, but harmony. The forms repeat, not by accident, but by the quiet logic of nature. The branching of neurons, the spread of mycelium, the flow of rivers, the weave of galaxies, all are expressions of connection. All remind us that we are part of a single fabric. From a meditative view, these analogies also teach acceptance. Just as the web of neurons makes thought possible, the cosmic web makes galaxies possible. Just as the web of mycelium nourishes forests, the cosmic web nourishes clusters with gas. Just as rivers carve valleys, gravity carves filaments. Each system is vast in its own way, each one patient, each one unfolding with its own rhythm. You might picture the analogies now, softly layered. A neuron glowing in the brain, a thread of mycelium weaving through soil, a river branching into streams, a filament of galaxies stretching across the sky. Different in substance, identical in shape. Different in scale, identical in spirit. Together, they reveal a unity of design, a calm that crosses every boundary of size. That our place in this picture is not small but central. We carry networks within us, neurons firing, blood flowing, breath circulating. Around us, networks sustained forests, rivers, and ecosystems. Beyond us, the cosmic web sustains galaxies. At every scale, life and matter arrange themselves into patterns of connection. To notice this is to feel belonging not only to Earth, but to the universe. As you breathe again, slowly and evenly, you may feel yourself as part of a network too. Your body within nature, nature within Earth, Earth within the galaxy within the cosmic web. Each level repeats the same gentle form, branching and connecting, holding and flowing. The analogies are not just images. They are reminders of unity, harmony, and calm. Let your breath find its rhythm again, slow, steady, unhurried. As you rest in this rhythm, imagine another rhythm unfolding across scales far beyond human life, the rhythm of cosmic time. The web of the universe is not frozen. It has a history, and it has a future. It is shaped by time, just as surely as rivers are shaped by their flow. To reflect on time in the cosmic web is to glimpse patience on the largest scale imaginable. The story begins nearly 13.8 billion years ago, with the Big Bang. At that moment, the universe was hot, dense, and nearly uniform. There were no stars, no galaxies, no filaments, only a smooth soup of particles and radiation. Yet even in this uniformity, there were tiny fluctuations, slight differences in density, perhaps no more than 1 part in 100,000. These ripples, preserved in the cosmic microwave background, were the seeds of everything to come. As the universe expanded and cooled, gravity began its patient work. Denser regions pulled matter inward, while less dense regions lost matter outward. Over millions of years, the first threads of the cosmic web appeared. Gas fell into these threads, forming the earliest galaxies. By about 1 billion years after the Big Bang, the web had taken its first recognizable form: filaments stretching, voids opening, clusters brightening. Time in the cosmic web is measured not in centuries or millennia, but in eons. A single filament may require billions of years to grow into its full size. Galaxies drift slowly along its length, like leaves on a stream, merging and gathering where filaments intersect. The clusters at these intersections become brighter with time, while the voids grow emptier. The web is not static. But its changes are so gradual that from our perspective, it seems frozen. The galaxies we see today carry within them the memory of this time. Their stars hold clues to when they formed. Their motions reveal the flows of matter. Their shapes tell stories of mergers and collisions. Each galaxy is a record of billions of years, a living archive of the web's evolution. To study them is to read the diary of cosmic time. As billions of years passed, the web grew clearer. Dark matter provided the invisible scaffolding, guiding ordinary matter into filaments. Gas cooled, forming stars and planets. Black holes grew in the centers of galaxies, shaping their surroundings. By 5 billion years after the Big Bang, many of the structures we see today were already present, though fainter and less developed. Time has only deepened them, drawing the contrasts more strongly, widening the voids, sharpening the filaments. In our present age, the cosmic web spans the observable universe. It is mature, structured, and grand. Yet even now, it continues to change. Galaxies still fall along filaments into clusters. Clusters still merge into larger ones. The web continues to stretch as the universe expands, its filaments pulled longer, its voids widened. Every moment of your life, every breath, coincides with this slow unfolding. The future of the cosmic web is shaped by dark energy. As space expands more quickly, galaxies not bound together by gravity will drift beyond visibility. Clusters will remain intact, but the filaments connecting them will thin. Over trillions of years, the web may become sparser, its threads stretched, until they fade into darkness. The largest structures will persist, but the visible universe will look emptier. This is not a sudden change, but a slow fading, like the dimming of embers in a fire that has burned for an eternity. To contemplate this timescale is to release urgency. The cosmic web evolves, but it does so with infinite patience. Civilizations may rise and fall, stars may live and die, yet the web continues its slow rhythm. Human history, measured in thousands of years, is less than a blink against billions. And yet, within that blink, we are able to perceive the whole story, from the first ripples to the distant future. That awareness itself is remarkable. There is a soothing lesson in this. The web teaches that time is not only about speed and urgency, it is also about endurance and rhythm. The voids remind us of silence. The filaments remind us of connection. The clusters remind us of gathering. All of it unfolds across time, not rushed, not forced, but natural. To rest with the web is to feel that time, too, can be gentle. Analogies help us hold this thought. Think of a tree. Its growth is invisible moment to moment, yet across decades, branches spread, roots deepen, rings accumulate. The cosmic web is the same. From moment to moment, it appears unchanging. From eon to eon, it evolves into vast structures. The patience of a tree is a small echo of the patience of the cosmos. Even our place in the web is marked by time. The Milky Way has orbited the center of the local group for billions of years. In 4 billion years, it will merge with Andromeda, forming a new galaxy, sometimes called Milkomeda. This event will not be sudden. It will take hundreds of millions of years, stars drifting past one another, new structures forming. To us, it will be a transformation so slow that no generation will notice. To the cosmic web, it is simply part of its rhythm. Ultimately, the story of time in the cosmic web is the story of becoming. From uniform beginnings to patterned grandeur, from faint ripples to filaments spanning billions of light years, the universe has unfolded steadily, guided by gravity and expansion. It continues to unfold, and it will do so long after we are gone. The scale is immense, but the lesson is intimate. Time is spacious, and in that spaciousness, there is room for calm. As you breathe again, you may imagine time itself as a filament, stretching from the past to the future, with the present as one glowing point along its length. Behind lies the history of galaxies forming, stars igniting, clusters merging. Ahead lies the slow fading into greater silence. You are here now, resting within the thread. The rhythm of the web and the rhythm of your breath are not separate. Both are part of the same unfolding, timeless, and serene. Let your breath settle once more, slow and even. With each inhale, imagine clarity entering. With each exhale, imagine release. As we turn to the subject of limits, it is important to remember that limits in the universe are not barriers to fear, but horizons to rest upon. They are the edges of what we can see, the gentle boundary between the known and the unknown. Tonight we reflect on the limits of observation, the ways in which our view of the cosmos is both vast and finite. When we look into the night sky, we are not only looking across distance, we are looking back in time. Light travels at a finite speed, about 300,000 kilometers per second. It seems instantaneous to us, but even light from the sun takes 8 minutes to reach Earth. Light from the nearest star takes more than 4 years. Light from the Andromeda Galaxy takes over 2 million years. Each star we see is a memory, each galaxy an echo of an earlier moment. The farthest we can see is called the observable universe. It is not the entire universe, but only the region from which light has had time to reach us since the Big Bang. This region has a radius of about 46 billion light years. Beyond that, the light has not yet arrived. It may exist, it may contain galaxies, filaments, and voids, but it lies outside. Our horizon. The observable universe is like a sphere around us, centered on Earth, but not because we are central, only because we are observers. Every observer anywhere in the cosmos would see their own sphere. This horizon is one kind of limit, the limit of time. Because the universe has an age, there is only so much of it we can see. As time passes, the horizon grows, revealing more. Yet dark energy ensures that distant galaxies move away faster, and some will never come into view. The expansion of space means that the horizon is not simply a circle widening, but a delicate balance between light traveling in and galaxies rushing out. Another limit comes from opacity. In the first 380,000 years after the Big Bang, the universe was so hot and dense that light could not travel freely. It scattered constantly off charged particles, like a beam of light bouncing endlessly through fog. Only when the universe cooled enough for atoms to form did light escape. That ancient glow is the cosmic microwave background, the farthest wall of light we can see. Beyond it, the universe remains invisible, not because it is absent, but because it is hidden behind the curtain of its own beginnings. There are also practical limits. Our telescopes, as powerful as they are, cannot capture infinite detail. Distant galaxies appear faint, stretched by redshift into longer wavelengths. Some are so dim that even our largest observatories can only guess at their presence. Dust within the Milky Way blocks parts of the sky, creating regions where we cannot peer outward. Instruments are bounded by sensitivity, by design, instruments are bounded by sensitivity, clarity of Earth's atmosphere, or the reach of satellites in orbit. And yet, these limits do not diminish the wonder. They frame it. They give our knowledge edges, shapes, and horizons. To know that we cannot see beyond the cosmic microwave background is not to despair. It is to marvel that we can see that far, at all nearly 14 billion years into the past. To know that some galaxies lie forever beyond our horizon is not to feel loss. It is to rest in the richness of those we can see, tens of billions already known, each a city of stars. The limits of observation are also invitations. They call us to imagine. What lies beyond the observable universe? More filaments, more voids, more clusters, perhaps structures even larger than the Hercules Corona Borealis Great Wall, or perhaps regions very different, shaped by fluctuations we cannot measure. We do not know, and perhaps we never will. But the act of wondering connects us to the unknown, like standing at the edge of an ocean and gazing toward the horizon. The horizon is not an end. It is a beginning of imagination. There is comfort. In this, too, limits remind us of proportion. Our tools are finite, our lifespans brief, our perspectives narrow. Yet within those boundaries, we have reached astonishing distances. From a small planet, we have charted billions of galaxies. From fragile instruments, we have detected the afterglow of creation itself. What we cannot see does not erase what we can. The known and the unknown coexist, like light and shadow, each giving the other meaning. In meditation, boundaries often become places of rest. The pause between breaths is not absence, but balance. The horizon of vision is not emptiness, but orientation. In the same way, the limits of observation are not failures of science, but natural horizons of being. They remind us that knowledge, like the universe, unfolds gradually. Each generation sees further, builds deeper, imagines wider. The horizon shifts, but it never disappears. Even within the limits, there are layers of richness. Radio telescopes reveal invisible wavelengths, uncovering structures hidden from the eye. Infrared telescopes pierce dust, showing stars being born. X-ray observatories capture the glow of hot plasma in clusters. Each window opens new details, expanding the map of the cosmos. Together, they weave a fuller picture, reminding us that limits in one view may be opportunities in another. To rest with the limits is to accept mystery. The universe does not reveal all at once, nor does it need to. Its vastness is a source of calm, precisely because it is beyond us. We are not required to know everything. We are allowed to wonder. The horizon is not a wall, but a soft edge, a gentle boundary where knowledge meets possibility. As you breathe again, you may picture the observable universe as a glowing sphere. Around you, filled with galaxies, clusters, filaments, and voids. Beyond the sphere lies more unknown, unseen, but present. The edge is not sharp, but soft, like twilight blending into night. You are here, within the sphere, resting safely inside, the horizon of observation. And beyond, the universe continues, infinite in its calm. Let your breath settle, slow and even, like the turning of planets around a star. As you rest in this rhythm, allow your thoughts to stretch forward, beyond today, beyond centuries, beyond even the life of the earth. The universe itself has a future, written not in sudden events, but in the slow unfolding of time. To reflect on the future of the universe is not to feel fear, but to sense the immensity of patience. The cosmos does not hurry. Its story extends across trillions of years, a quiet rhythm of expansion and change that at present the universe is expanding. Galaxies drift apart, carried on the flow of space itself. Dark energy ensures that this expansion is not slowing but accelerating. Over billions of years, the fabric of the cosmic web will stretch wider. Filaments will grow thinner, voids will widen, clusters will drift farther from one another. Yet within each cluster, gravity will hold galaxies together, binding them even as the universe beyond slips away. In about 4 billion years, the Milky Way and Andromeda will merge. This will not be a sudden collision, but a slow dance, lasting hundreds of millions of years. Stars will pass one another almost without contact, their orbits shifting into new patterns. Gas will compress, earthing new stars, while the central black holes of the two galaxies spiral inward, eventually merging. The result will be a single larger galaxy, sometimes called Milkomeda. To future observers, the night sky will glow differently, yet the rhythm will be serene. Farther ahead, tens of billions of years from now, star formation will slow. Galaxies will exhaust their supplies of gas, and fewer new stars will be born. The universe will grow quieter, its light dimming as young stars give way to older, cooler ones. Red dwarfs, small and steady, will endure the longest, burning gently for trillions of years. They will keep the cosmos lit even as brighter stars fade. On longer timescales, galaxies themselves may change form. Mergers will create giant ellipticals, calm and featureless, their spirals erased. Within clusters, galaxies will merge into single massive systems. Gravity will gather what remains, while dark energy ensures that distant clusters drift away, unreachable. Over time, each cluster will become an island, isolated in the widening ocean of space. If we look trillions of years ahead, even red dwarfs will fade. The universe will enter what some call the degenerate era, when most of its light comes not from shining stars, but from faint remnants, white dwarfs cooling slowly, neutron stars radiating weakly, black holes quietly distorting. Space, the cosmic web, will persist in shape, but it will be less luminous, its filaments glowing only faintly. And farther still, after unimaginable spans of time, black holes may dominate. Galaxies will have merged into single giants, and within them, black holes will grow larger, consuming matter and merging with one another. Even they are not eternal. Over quadrillions upon quadrillions of years, black holes themselves may evaporate through a process called Hawking radiation, releasing their mass as faint particles until nothing remains. The universe will become darker, quieter, thinner. Yet even this is not an end. It is simply another phase. Some theories suggest that the universe may expand forever, its galaxies fading beyond the horizon until only emptiness remains. Others imagine more exotic endings. A big rip in which dark energy grows so strong that it pulls apart galaxies, stars, planets, even atoms. Still others suggest cycles, with expansion one day giving way to contraction, followed by a new beginning. The truth is uncertain. The future of the universe is an open horizon, a story still unfolding. What is certain is the rhythm, slow, patient, unhurried. The timescales are so vast that even the entire history of life on Earth is less than an instant by comparison. Human civilizations rise and vanish, stars are born and die, and still the universe moves calmly forward. Nothing in its unfolding is rushed. Nothing in its rhythm is fragile. It endures. For us, these visions of the future need not inspire worry. They are so far beyond human time that they become meditative rather than urgent. To know that stars will shine for trillions of years is to feel security. To know that galaxies will drift calmly, guided by gravity and dark energy, is to feel continuity. The cosmos does not end in suddenness. It stretches outward in gentleness. There is also a lesson here about acceptance. The universe will not remain. As it is, it will change. Structures will fade, light will dim, horizons will widen, and that is natural. Change is part of existence, not only on Earth, but on the largest scales. The web itself teaches impermanence, yet impermanence without fear. Just as breath comes and goes, so galaxies form and dissolve, and the universe continues its patient rhythm. You may picture the future now, not in detail, but in mood. Imagine galaxies fading into distance, clusters glowing faintly, voids stretching wider. Imagine stars dimming, one by one, until the sky becomes quieter, softer, more spacious. This is not destruction, but transformation. The universe is always becoming, always unfolding into new forms. From our perspective, here and now, the future of the universe is less about prediction and more about wonder. We cannot know exactly how it will end, or if it will ever truly end. But we can know that it will continue, that its rhythm is vast, and that within its patience, there is calm as you breathe once more, slowly and evenly. You may imagine yourself floating within this cosmic timeline. Behind you lies the long history of the web, its birth, its growth, its present form. Ahead lies its future, its stretching, its fading, its transformation. You are here, now, one point on the thread of eternity. And in that place, within the vast unfolding of time, you are safe, held gently by the same forces that guide the cosmos itself. You've been listening to the Sleepy Brain Dose. As the story of the cosmos fades into silence, may you carry with you a sense of calm and connection. The universe is vast, patient, and serene, and within it, you too can rest. Close your eyes. Let the rhythm of your breath match the rhythm of the stars, and drift gently into sleep.